In this video, we'll talk about the different number systems and how they are used to communicate with computers. Computers speak and understand in a different way than people. We can comprehend ideas and pictures and such. Computers only think in numbers. More specifically, not all numbers, but just in ones and zeros, which is considered binary. Computers speak and understand only binary. This is a base 2 number system using typically zeros and ones. So why do they use binary? Binary is easily understood for a computer. There is no gray area, but rather something is definitely on or definitely off, like a light switch. If there were more values, like when you use a dimmer switch, you have gray area values, like sort of on, or maybe just a little off. A number system defines how numbers are used. You may think there's only one number system, the one we're used to, where we use 10 digits, but there are actually a lot others. The system we are accustomed to is called the decimal number system. There are 10 digits used in this system, starting with 0 and ending with 9. The binary system only includes 2 digits, as we mentioned before, but there's actually other systems as well. The Maya number system, for example, has 20 digits. They use mostly a combination of lines and dots to represent these values. Can you imagine a system that uses 60 digits? The Babylonian number system does just that. All number systems work exactly the same, just with a different number base. Let's take a look at how number systems work, starting with the one we're most common with, the decimal number system. The way this works is that we use all the digits 0 through 9, and once we run out, well, then we put a 1 in front and then use 0 through 9 again. When we run out again, well, this time we'll place a 2 in front and then go through 0 to 9 again. The binary system works in a similar way, but with only 2 digits available, we'll have to start using combinations of digits much sooner. Once we've used 0 and 1 already, then we start with a 1 and then use 0 and 1 again. Once we do this, we've run out of options again. So this time we start with 1, 0 and then use 0 and 1 again. We can also use 1, 1 and then 0 and 1. What do you think happens next? Next, we'll use 1, 0, 0 and then 0 and 1. And then 1, 0, 1 and 0 and 1. And it continues on. We can also convert numbers from one system to another. Before we do all that, let's explore how a number in the decimal system is broken down into place values. This will help. We'll take 6,932 in decimal form and break it down. First, we'll split the digits in the number. The place value system in decimal works off the base value of 10. So there are ones, and then there's tens, hundreds, thousands, and so forth. Another way of showing this is using the base 10 and increasing the exponents. We then multiply the digits by the place value they belong to and add these numbers together. This might seem repetitive, but we'll follow the same process to convert a binary number into decimal. The base is different in binary. We'll start the same and split up the digits. The base here is 2, though, so instead of multiplying by 10 for the place values, we'll multiply by 2. Starting from the right, you can see that the number doubles each time. We can use base 2 and increase exponents to simplify this a bit. We still multiply in this step, but there are many zeros, and 0 times anything is still 0. Lastly, we add up the numbers to convert the binary number to 145 in decimal form. All right, now it's your turn to dive deeper and explore more about these concepts.